Hello guys, in this video we'll learn about natural language processing NLP using Rust. The purpose of this video is to understand how to work with natural language processing or NLP using Rust, so in the future videos we can integrate these models separately in our projects for different use cases. In this video we'll cover most common natural language processing techniques. We'll start with translations, where we translate a sentence from one language to another language. Then we'll cover parts of speech, where we tag different parts of a sentence with respect to different parts of speech. And we'll look at keyword extraction, where we extract keywords from a text. Sentiment analysis, where we classify or tag particular sentence as positive or negative. And text summarization, where we summarize a huge amount of text. Text classification, and we'll also learn how to run these models on CPU as well as on GPU. But if you are running on CPU, I assure you these models are pretty lightweight and you can easily run on your CPU machine as well. This will be one of the most detailed video on natural language processing using Rust on YouTube. So make sure you hang tight, watch till the end, and if you have any queries, feel free to drop in the comments, or you guys can join on my Discord. So let's begin. First of all, move to the Project Explorer and make sure you have a clean cargo package. Open the cargo toml file. We'll add a few dependencies. The first one we need is rust-bert, which is the natural language processing dependency. And the second one we need is a wrapper to PyTorch. So we'll add both of these dependencies, and you might as well just run cargo add rust-bert and cargo add tch to add both of the dependencies in your project. Once the dependencies are added, we'll move to main, and first of all we'll start with the translation model. So we'll add a function translation, and we'll be using the model translation model. So model translation model builder new, and with device, and here we can just add device from tch. Now if you know you have CPU already, you can just use CUDA and specify the number, and if you don't know, then you can just use device and CUDA if available. So basically it will check if there is CUDA available, otherwise it will just use the CPU. So then we'll just add the model type with model type, and here we'll use model type and Marion. Now if you go inside, you can see there are tons of models that we can use, but I'll be using this most renowned model for translations. And then with source language, you have to specify the source language, so the model will be downloaded accordingly. But here the good part is you can specify the vector of source language. So let's say for me the source language will always be English, and with target language, again target language is also a vector, so you can specify as many as you want, but let's say for now I'll just specify a single language, Spanish. And then we'll just do create model and unwrap. So we get our translation model, and then we'll add the text. So let's say the text, hello, how are you, please subscribe. So let's say this is our text, and you can write as much text as you want, and you can also have multiple text as well, feed it a single time. So let's say model dot translate, and here we will pass our text. So since I just have a single text, so I'll just use text, and if you want to re-specify the source language you can, otherwise just none. And the target language, because here we can remember specify multiple languages, so let's say Spanish and other languages, let's say Korean, Japanese, Chinese, or even other French languages. So we can specify as many languages as one, but what exact we want to translate this text to, we have to specify here. So let's say I'll just specify Spanish, and once we have that, we'll just do unwrap. So we get a vector of string, as you guys can see, because there can be multiple text that we can feed. I'm currently just passing single text, but we can have multiple text pass as well. And then just we can, do a loop over sentence over output. So we can just say sentence and output and print and sentence. So this will just do the translation, and I'll let you know, guys, this is pretty fast even on CPU. So let's say if you want to use it for your projects, it's pretty quick. So let's do it for the first time. Yes, it will take like a 2 odd minutes depending again on your machine, but to download the model and get it ready. But once you are done with it, next run, it's just pretty fast. So let's run this and test it. So translation, and we go to our terminal, and here we'll just do cargo run quite, and there you go, we get our translation in Spanish. Now similarly, let's say I want to translate to a different language, maybe French. So we go with French, and also here we have to change to French, and let's rerun. And there you go, we get immediate output in French. So this is how easy it is to work with translation NLP model and do the translations of your text without using any Google API or even OpenAI or any such translation API which is paid. This one is just for free. Just run the model and do the translations. So you can easily add it in your project, side projects, and get it done for free. So now let's move to the next one, which we have is parts of speech. So let's remove this and let's move to parts of speech. So we'll just use a POS model. So POS or part of speech. So POS model new, and we'll keep everything as default. But if you want to set the config, you can provide the config, but I'll just set to default, and then unwrap, let input, and here again we can specify as many sentences as we want. So I'll just put a single sentence, hello, how are you doing, and then we do the output POS model dot predict, and we pass the input. Then for POS and the tag that we get, and output, as you can see, it's vector. So we'll just pick 0 iter and enumerate. So print. Now here we'll just do POS and tag, and let's run this. So basically we'll tag each part of this sentence in different parts of speech, which you might have learned in your school, like noun, pronoun, adverb, punctuation, and all those stuff. So let's run this and test it out. So move to the terminal, and we'll again do cargo run. So here you go, our output, and as you can see, hello is a noun and comma is a determiner. Then we have how, which is an adverb, and then we have are, which is a verb, non-third person singular present, and then we have same as are and you, and then we have doing, which is verb gerund, and then we have question mark, which is punctuation. So as you can see, all of these are tagged properly. So our sentence has different parts of speech which are tagged, as we just see, and as you can see, it's pretty easy. And let me know in the comment which use case or which project can you include it in, and it will be pretty interesting because you're not using any API, any paid tool. It's just a model. You spin it up on your machine and then that's it. Now let's move to the next one, where we can do sentiment analysis. Maybe we'll do keyword extraction and summarization and classification afterwards. So let's move to sentiment analysis. So let's remove this. So for sentiment analysis, we'll just use sentiment model. So sentiment and analysis. So we'll just do sentiment classifier and sentiment model, new, and again we can add, but we can also use default. So default and unwrap. We get our sentiment classifier model. And now let's add the input. So input, and let's do this movie is the worst I have seen. And the second sentence we write is, this is the best YouTube channel for Rust programming language. And I tell you guys, this is not a lie, right? So just subscribe. And now let's run the model. So we'll just do let output sentiment classifier predict input, and for sentiment in output we can just do print and sentiment. So let's run this and do the sentiment analysis. Now this could be very useful. Let's say you are building a website where you want to do review analysis or feedback analysis for your customer, and based on that you want to decide to send out maybe the vouchers to a customer who had a bad review, so you want him to book with you guys again or maybe purchase with your website again. So you can use this sentiment analysis model where you can check for the sentiments of the user, and based on that you can recommend them things, or maybe give them vouchers or discounts. And again, as you can see, no API required, this is free. So let's move to keywords extraction. So let's remove this and this. So fn keyword extraction. Now this can be very useful in the use cases when you have a large amount of sentence or text, and based on certain keywords, certain important keywords, you want to use those keywords to maybe recommend some things to the user, just how we have seen in ACO tools, or even on Medium, when you upload your article you get some keywords. So similarly, so we'll just use keyword extraction config and keyword extraction config. So sentiment embeddings config and sentiment embedding config from. So here we can just add embedding type, sentiment sentence embedding model type, and we'll use all minimum LMV2. You can look around different options that are available, so I'm just using this one, but you can also use different other models and have it a go. Now we'll just use scorer type. So scorer type as keyword scorer type, and we have different here cosine similarity. There is lots of description as well, so you can learn about it. Maxsum or maximum margin relevance. So I'll just use maxsum. And then we have anagram range and 1 and then we have number of keywords, how many keywords are needed, let's say 5, and rest everything I'll just keep default. So we have our keyword extraction config. Let's give it a model. So keyword extraction model, and we can just do keyword extraction model new, pass the config. So keyword extraction config and unwrap, we get our model. Now let's add an input. So here's the input, a long paragraph from Wikipedia. Now you guys can also copy from Google, or you can type your own. So we'll just do let keywords keyword extraction model dot predict and pass on our input. Now again, it's a array, so you can pass as many as you want, but I'll just stick to a single, and unwrap. So we get our vector of keywords, vector of keywords, because we can pass multiple input sentences or paragraphs. So for keyword in keywords, and we'll just pick 0 and iter. So we can just do print, and so here we can just do keyword dot text and keyword dot score. So we get the score and the text as well. Now let's go ahead and do keyword extraction. So as you can see, nice and clean, very simple. So open your terminal, and here we'll just do cargo run. There you go. As you guys can see, we get our 5 keywords as we just define here, and then we get the score as well, which is the most keyword. So there you go. As you can see, we did the keyword extraction as well. Now let's move to the next one. Now let's move to the text classification, and the final one we'll cover is text summarization. So for text classification, we'll just do let classification model, and here we'll just do 0 short classification model new, and default unwrap, keeping everything else, the configurations default. And then we'll just do let input sentence. So which sports do you play? And let's say this is one of our input, so input 1, and the second input I do is who is the prime minister of your country? And here we give the candidate labels. So candidate labels, and so let's say politics, sports, public health, or drama, or I would say universe, or any other label that you got to give. So let output and classification model predict multi-label, and here we can pass on our inputs. So input 1, input 2, and once we have both the input, we'll pass the candidate labels, some, and the template. So box new. So here we'll just give the label and format. So example is about label. So this is the template, and max length as, let's say, 128, and that's pretty much all we need in the config. Unwrap to get the output, so print ln output that we get. So that's pretty much all we need here for text classification. Let's do text classification. Again, this can also be useful. You can, have some candidate labels based on customer feedbacks, and then you can feed in your customer feedbacks and see what's the label most matched against your input. And you can also create filters on basis of that. So let's go to the terminal. So we'll just do cargo run quite. So here you go, our output, and as you can see, example is about sports, the first example that we had, and the second example, and then because it's multi-label, so it's predicting against all the labels. Politics at 0.02 score, sports is high, and then there is public health, which is 0. Then the second one that we had is example about politics is 0.9, and basically, as you guys can see, all of the input that we had, it has classified the input. Now let's move to the next one, which is text summarization. So the last one which is left is text summarization. Other than that, we have covered pretty much everything. So move to main and summarization, and let config resource box new remote resource and from pre-trained. So here we'll just add BART config resources, and we'll pick CNN66. And again, there are different examples that you can try and check against each, but I'll just stick with this one. And then we have vocab resource. So let's add vocab resource box new and remote resources from pre-trained again. And here we will have BART vocab resource, and again I'll pick CNN66. Similarly, we have merge resources box new and remote resources from pre-trained. So BART merge resources and 66 again. And lastly, we need model resource. So box new and remote resources from pre-train. Based on your use case, you can check which one suits the best, but I'm just checking using one of these. So model resources 66. As you can see, there are lots of resource, lots of examples, lots of options actually, so you can try all of these. And we'll just add summarization config and model resources as model resource torch, model resource, config resource, vocab resource, and merge resources, some merge resource, and number of beams, I'll just set it to 1, length penalty as 1.0, and minimum length as 56. This is the minimum length, and max length as, let's say, 200. Device, again you can specify here. If you have GPU, just CUDA, and then if you have multiple GPU, 0, 1, 2, 3, but I just have CPU, so we'll use CPU default and default. Keep everything else as default. Some 200 as max length is optional, and then we'll just use summarization summarization model new, and pass on the summarization config and wrap. So we have our summarization model. Now we need the input. Again, since we need summary, so we need the lengthy input. Now you can either type it out or ask GPT to generate it, or even you can use something from internet. So I just dumped this input, and either you can use the same or just write your own. And output summarization model dot summarize, pass the input dot unwrap. And again, since it could be multiple inputs that we can provide, it's an array, so multiple outputs. So, or we can just do print. Since we know it's single, we don't need to loop. We can just do sentence or output. And that's it. So let's run this and see how the summarization model works. So open your terminal and just do cargo run quite. And there you go. As you guys can see, we have our summary, and it looks smaller compared to how huge our input is. But this is a very small summary that we get for our input. And as you can see, it's a model which is downloaded and then basically run on local, but it doesn't take too much time. So you can also try summarization on your site. So that's it for this video, guys. I hope you guys understood and learned all of these concepts. Try out on your end, because as you guys can see, there are multiple models that are provided in Rustbird for NLP purposes. We just use just one variant of each of the models that we have for different use cases. You guys can try out all on your site, and let me know in the comment what do you guys think, where we can apply these in our use cases of our Rust projects. So that's it for this video. I'll catch you guys in the next video. Bye bye.